Second lecture of systems of track electrification. So mainly three type of track of electrification. First is DC system, second is AC system. The sub part of AC system is single phase system and three phase system, and the main third part is composite system. Then the composite system is divided basically in two types: single phase AC to DC system and single phase AC to three phase system. This is the system of track electrification. Now the each and every part, DC system, AC system and composite system, we will see further. The first is DC traction. DC traction unit use direct current drawn from conductor, rail or an overhead line. The most popular line voltage for overhead wire supply system is 15 kW DC and to 30 kW DC. 600 volt to 750 volt DC volt range is used for third rail system. Additional rail is provided for supplying electricity to train and is called conductor rail. This is in the figure we can see the electric system of DC. The overhead wire is DC supply, and the current collector is collect the DC supply and give to motor control, and motor control is control the speed of motor and give the supply. The disadvantages of this DC traction system is expensive. Substation are required at frequent interval. The overhead wire or third rail must be relatively large and heavy. Voltage goes on decreasing with increase in length. So this is the major disadvantages of DC traction system. So it's expensive substations. Now the next is AC traction. AC traction, in that the overhead wire have the single phase, neutral and phase. So it is the overhead wire is AC supply, and it give to transformer and transformer to rectifier. So it will be convert into DC and then given to motor control. So motor control can control and give supply to motor. So desired speed we can get from the motor control to motor. So AC traction unit draw alternating current from an overhead line. Typically voltage used are 25 kW AC 50 Hz or 25 kV AC 60 Hz. The advantages of AC traction system is fewer substations are required. Lighter overhead current supply wire can be used. So because the AC is alternating current, so lighter overhead current can be used. Reduce weight of support structure. As we know, in the DC we required third rail, but in this we not required. So it support structure is reduced weight. So reduce capital cost of electrification. So AC traction system is less costly as compared to DC traction system. Now the multi-system train are used to provide continuous journeys along route that are electrified using more than one system. One way to this is by changing locomotive at the switching station. This station have overhead wire that can be switched from one voltage to another. Another way is to use multi-system locomotives that can operate under several different voltage and current types. In Europe, it is common to use four system locomotives. First is 1.5 kW DC, second is 3 kW DC, the third is 15 kW and 16 2 by 3 Hz frequency AC supply, and the last one is 25 kW and 50 Hz AC. This is the block diagram of an AC locomotive. The overhead conducted wire, we use the brush for it. This is overhead conductor wire, then it given to pantograph. This is the current collector, and for safety purpose it use circuit breaker, and then it supplies given to rectifier. So the supply given to rectifier that convert AC to DC, and then it is given to our traction control, and that traction control the speed and give supply to DC traction motor. So in this system, this is the phenomena of AC locomotive. In electric traction system, there are many types of current collector, different types of current collector. So one by one we will see. The first is blow collector. A blow collector is one of the three main devices used on tram cars to transfer electric current from the wires above to the tram. It has now been largely replaced by the pantograph. So most probably use pantograph collector nowadays. So next topic is pantograph collector. Main function is to maintain the link between overhead contact wire and power circuit of the locomotive at varying speed in different climate and wind conditions. So second figure is about the pantograph collector. This most probably ask the GTU question: type of current collector, explain anyone. Catenary pantograph operation. This is the figure of again the pantograph we will discuss previously. This is the whole system of traction for making insulators, boost transformer. At the different place we put some phenomena to get the supply to the electric traction. This is the stage tube, contact wire, resistor arm. This is the current collector, actual current collector diagram. Oh, this is the pantograph, actual image of pantograph. The major component used in electric traction is traction substation, which provide the supply to the electric traction, and the overhead wire, which supply is coming from this wire. And the third is current collector. It is on top of the electric traction, so it will collect current from the overhead wire, which is coming from the traction substation. The fourth is track, which the direction and the track for the electric traction. And the fifth is traction system, or we can call it vehicle. So from the electric substation, the supply is given to overhead line, and then from the overhead line to our current collector to speed control system, and speed control system to electric traction motor, and the motor is will get the control from the speed control system and get the desired speed, so it will run on the track. This is the component of an AC locomotive. So AC current can collect from the pantograph, then it will be directly given to main rectifier. It will convert into DC line, and this supply is given to our control system. Now the part of electric locomotive, the first part is transformer. The line voltage has to be stepped down before use on the train. Traction transformer for trains and railway stock transformer. The overhead contact line voltage, which range mainly from 15 kW to 25 kW. To voltage suitable for traction, convert in 2.7 kW to 1.5 kW. Normally transformer use are of rating of 5600 kVA to 7200 kVA. This is the transformer used in electro locomotive. Next is the rectifier, the heart of traction. It will convert AC to DC. A rectifier consists of thyristor and diode, which is used to convert AC to DC. This rectifier is made from the power electronics devices. Instead of conventional bridge rectifier, thyristor are used for the power electronics device. A modern locomotive usually have at least two main rectifier. So this is the circuit diagram of the rectifier. This is our track. This is the pantograph, horns, overhead line, and contact strip. Traction motors. Mainly three type of traction motors are used: DC series motor, AC series motor, and three-phase induction motor. The feature of this traction motor is high starting torque, simple speed control, regenerative braking, better commutation, capability of withstanding voltage fluctuations. This is from the features from electrical. And mechanical features is light in weight, small space requirement, and should be able to withstand vibration. So this is use the motor, traction motor, and its features.